Okay, so we are back. Welcome. It's good to see you. Thanks for joining us. We are here in learning target number 7. Today we're looking at calculating the volume of a right triangular prism. So let's double check on a couple things that we talked about before. Our volume equals the area of the base times the height of the object. So in the triangular prism, the base is the triangle, right? If we think about triangular prism, the name is the base. So then we have the height, which is the distance between the two triangles. So if we see them like this, just remember it's the same thing as this. We flipped it up, and so we had our triangle on the bottom. We went up. Well, you get the point, right? Okay, we have our triangular prism. This would be the base. This would be the height. Okay, so let's take a look at this little example that we have here. So if we're looking at the area of the base, our equation for the area of a triangle is base times height divided by 2 times by the height of the object. So if it's labeled like this, you can also think length, right? You can either think flip it up, and here's the height, or you can think the length, because here we have a height of the triangle and a height of the object. So it might get a little bit wonky on you, but if it's laid out sideways, you can think of that also as length. So we have 2 options for our height. We have 9 or we have 5, remembering that the height of a triangle, scroll down a little bit, the base and the height of a triangle form 90 degrees. So if you look here, okay, here's 15, here's 9. Does this angle here make 90 degrees? No. So this angle right here goes straight up. That makes it 90 degrees. So that is the height that you're going to use. So we've got our 15 from down here. We've got our 5 from the height divided by 2. That'll give us the area of the base of this whole section of triangle. Okay. Times 20, because that's the length. 15 times 5 is 75, divided by 2, 37.5, times 20 equals 750 centimeters cubed. Remembering that we're going centimeters times centimeters times centimeters, because this area here would be centimeters squared, and this would be centimeters. So because we're multiplying them again, we're going to get centimeters cubed. There's 3 centimeters being multiplied in there. Okie dokie. The height of the object equals the length of the prism. So prisms often are drawn like this, down on their side instead of up and down. So remember that when it's up like this, the length, this length here, is what we're talking about when we're talking about the height of the object. Okie dokie. Cool. Let's move on to the next page. Okay, so let's take a look at this page right here. Now you'll notice we have a little typo in there. Surface area. This is not surface area. We're talking about volume. So we got volume equals base times height divided by 2 times the height of the object. So sometimes that might be written HO for height of the object, just so we know. The base and the height need to form 90, and the height of the object is the length, the difference, the distance between our 2 triangles. Okay, let's scroll down and take a peek and try a couple examples. So, numero uno, we have got, just in case we forget, let's write down our equation here. We've got volume equals base times height divided by 2 times the height. And if we want, we can have the height of the object. It's like a Santa Claus object. So, what do we know? We've got our base and our height of this triangle. Do those form a 90 degree? Yes. So we've got 4 times 3 divided by 2 times our length, or our height of our object, is 11. So 4 times 3 is 12 divided by 2 times 11. Oh, I ran out of space. I'm just going to move it up here. So 12 divided by 2 is 6 times 11. Now that's going to equal 66. Now I've taken out I haven't put in the units as we've gone, but we remember this is centimeters. And this whole thing is our area, right? This whole thing is our area. This whole thing is our area. And so this has been centimeters, centimeters. So this is actually centimeters squared. So we have 6 centimeters squared times 11 centimeters. And so that is going to equal 66 centimeters cubed. Okay. Got her? Excellent. Let's roll down to another one. I'm just going to switch. I can't tell if that's green or if that's red, just, you know, the world of the colorblind. So we can look at this one. It looks a little bit differently because it's flipped, because you might see it like that. But we can imagine, right? There's another triangle in the background here, right? So if we put our volume equals base times height divided by 2 times the height of the object. So what do we know here? We know our base, our height. Oh man, what do we use as the base? Do we use this as the base, 13? Do we use this as the base, 10? Thoughts? That's right. We're going to use the 10 because we see right here our 90-degree angle in our height. Okay. So our base is going to be 10. Oops, that looks like 16. 10 centimeters times height. Sorry, not centimeters. Millimeters times 12 millimeters divided by 2. I'm going to use the units here just to kind of reconfirm how we get to centimeters cubed. Okay, 10 times 12 is 120 divided by 2. Oh, 120 millimeters squared. Okay, divided by 2 times, what is our h going to be? Oh, we missed our h over here. Our height and our length, the distance between our two triangles is 14. 14 times 14 millimeters. 120 divided by 2, we have 60 millimeters squared times 14 millimeters. Let's type that into the old calculator. 14 equals 840. Actually, I'll put it down here. Equals 840 millimeters cubed. All right, so those are our examples. Remembering that our length or our height of the object, when we're looking at height here, we're looking at the distance between the two triangles, and when we're figuring out what our base is, which one to use as the base, it's the one that makes a right angle, okay, with the height. Awesome. That's it for today. Continue on. Good luck with this lesson number 7, working through the stuff. We miss you. We're thinking about you. Stay safe, and we'll see you again soon.